So I hope you guys are having fun listening to some interactions which are like their own experiences in bringing up these successful corporations. Okay, our next section, technology. So including green software, technology will be one of the greatest enablers of sustainability. In this session, which is our next session, we will cover what is green software, why as software practitioners we need to care about sustainability, and what it means to design and deliver green software applications. It is our pleasure to invite Naveen Balani, Chief Technologist, Technology, Sustainability, Innovation, Accenture, to present Uniting Technology and Sustainability, the Green Software Imperative. Please put your hands together in welcoming Mr. Naveen Balani. Mr. Balani, you have the mic, right?
Yes.
Great.
Can you all hear me? Well,
Do you want to try this?
yeah, good afternoon, everyone. I'm Naveen Balani. I'm a chief technologist with Technology Sustainability Innovation Group at Accenture. I'm also a Google Cloud certified fellow. So in this session, I'd like to talk about how do you unite technology and sustainability. Why as software practitioners we should care about sustainability, followed by an introduction to green software, and how do you design, develop, and deliver green software applications. So let's get started. So technology is no doubt a key enabler for sustainability. Technologies like AI, blockchain, IoT, all driving various sustainable use cases, be it transparent supply chain using technologies like blockchain, ESG monitoring and reporting, or maybe tracking real-time carbon using Internet of Things and sensors. But with the rapid adoption of technology, or in general any digital technology like AI, IoT, blockchain, is causing carbon emissions and hence greenhouse gas in general, which leads to global warming. And with the current exploration rate, it is estimated that in 2040, the carbon emissions from the ICT sector would be around 15%, which is quite alarming. Which is quite alarming. And which is quite alarming. And if you look at the 15%, right, that's half of the relative carbon emissions from a transportation sector. And if you look at technologies like blockchain, particularly in terms of the algorithm they use, like proof of work, it's quite energy hungry. And Bitcoin network is estimated to take electricity similar to a country like Switzerland. And when it comes to AI model, there was a research conducted where training a single AI model can emit as much emissions as 5 cars during the lifetime. So the point is, technology itself has a carbon footprint. And the way we design, develop, deliver applications needs to include sustainability as a first-class citizen. And that's where green software comes in, which is all about designing, developing, and delivering applications which emit fewer greenhouse gases. And when you talk about green software, right, you need to include green software as a first-class citizen throughout your software development lifecycle process, and includes similar to security or performance. Green software should be one of the key parameters. And when you talk about green software, right, we are looking at this space holistically on how can you identify carbon reduction opportunities throughout your software development lifecycle. And so we at Accenture has broken down into 7 material impact areas. It all starts with green software development lifecycle. For instance, what choices you are making for architecture, what programming languages you are using, and how do you integrate carbon footprint as part of your DevOps process. To give you some example, Python and JavaScript are 2 of the widely used language, but they consume 40x times more energy than semi-compiled language. Architectures like serverless or event-driven architecture are more energy efficient. I just read a recent blog where there was an implementation, a sidecar implementation from Kubernetes being moved from JavaScript to Rust, which is the second most energy efficient language, led to 70% reduction in CPU and around 80 to 90% reduction in memory, leading to more carbon efficient system. And it's not about efficiency, it also reduces your cloud cost. And it's not just about moving to energy efficient language, right? You need to understand the various trade-offs. For instance, you will not move your for your ML machine learning development, right? You will not move from Python to C because the required libraries are not available or you don't have the required skills. But you rather start optimizing your process to be more energy efficient. The second area that we are working on is green user experience, on how can you create energy efficient UI applications, be it for web, mobile, or in future metaverse. For instance, how do you create energy efficient 3D models, energy efficient 3D scenes? How do you blur the virtual and the physical reality in an energy efficient way? How do you simplify user journey? And with green software, we now have an opportunity to get and build energy efficient metaverse right from day one. The third area that we are looking at is green AI. So if you look at a typical AI or ML lifecycle process, it has various stages. For instance, you have data acquisition, data cleansing, data validations, model building, and you iteratively develop models, and then you finally have an inference model and you do an AI delivery. So at each stages of the AI ML development, you can bring in carbon reduction opportunities. For instance, how can I create sustainable data pipelines? How do you take care of accuracy and energy efficiency? What kind of ML architectures and framework you can use? Can I use a pre-trained model rather than developing my own model? And we did a very simple experiment of a relatively small AI model, and we found out that gaining an accuracy of 2% from baseline led to 700% jump in energy. So basically, you need to be aware of when do you want to stop training your AI model and build all these AI principles as part of your green AI practice. The fourth area is around blockchain, on how can you create energy efficient blockchain applications. For instance, how do you design the blockchain network? How do you create smart contracts? And especially with the talk around digital currency and non-fungible tokens, blockchain will play a significant role. So we have an opportunity now to create applications in a more energy efficient way. The fifth area is around data. So data is key assets for any organization. But what we have seen is data has been accumulated over the years by organizations with the intent that it might be used in future. And data that is lying somewhere in the enterprises constitutes around 70 to 90%, which is called dark data, which is never used for any meaningful insights. And personally, also you can relate it, you get a 15 GB storage space and you keep uploading photos. And your storage space, it either gets increased and then you start deleting it, or you buy more storage. So in terms of green data, you have to look at this space holistically on how can you do proper data relevancy as part of your application. What kind of data architecture and storage you should use. So all these practices needs to be applied as part of your green data practice. The sixth area is around green cloud and edge. And moving to cloud definitely helps you to provide, inherently gives you carbon reduction opportunities, because cloud is likely to run on renewable energy. From a data center perspective, they are more optimized than a traditional data center. And once you move to the cloud, right, the other challenge is how do you use cloud responsibly from a sustainable perspective? For instance, what kind of virtual machine should I use? A lot of cloud vendors offers energy efficient virtual machines. You need to evaluate the right virtual machine or right size virtual machines to use, which offer better utilizations. When it comes to architecture, are you using serverless architecture for better resource utilization? And next is definitely if you migrate to a cleaner region, right? Let's say from Asian region to a region UK, you can directly save up to 60% carbon reduction. And the last is the infrastructure, which basically drives the underlying supporting infrastructure for you. So be it laptops, servers, and how do you do proper recycle and proper end of life cycle management? Because all these adds to the embodied carbon. So green software being a relatively new area, all organizations needs to come collectively, apply their collective thinking to create new specifications and innovations in green software. And that's why we co-founded the Green Software, which is an Linux, open source Linux community for advancing green software development and principles. So as part of Green Software, we started with 4 organizations. We are now a 32-member organizations. And all are working towards 4 key aspects. The first one we are working on is specifications, creating the first specification, which I'll talk about in the next slide, called software carbon intensity. We are driving a lot of innovations on what tools would be required for green software development in terms of measurements or in terms of carbon or making your applications carbon aware. The third thing we are focusing on is community, providing awareness, and also the first ever green software certification. This is being planned somewhere in December. And the fourth we are working on is policy, on how can you work with various organizations from a policy and trademark perspective. So last December, we launched the software carbon intensity specification. So one of the questions frequently asked is, right, as a software developer or a practitioner, how can I measure the carbon footprint of my software application? And that's where the software carbon intensity comes, which provides a practical methodology and approach to measure the software carbon footprint of your application. And what's unique about software carbon intensity specification is that it is action-oriented. It's probably the first specification which talks about reduction and not offsets. So you're not buying carbon offsets. The whole focus is on reduction, on how can you basically create applications which are more energy efficient. And SCI is basically a score. And in order to reduce the score, there are three key principles that you can apply. First is how do you create energy efficient software application itself. Second area is around hardware optimization. Can you use less hardware for same amount of work? And third being carbon aware. You're using carbon aware or shifting your workloads where there is clean energy. And SCI is basically an iterative process. We are planning to release version 1 in the next few months. And from a methodology perspective, it is built in a way so that any software practitioner can develop it. It consists of five phases. So you all start with defining the software boundary. For instance, what is my software stack? And for each of the software stack, you go about calculating it, whether it's a real labs measurement or directly from your production server. You define the functional boundary, and you also define the functional unit. For instance, function unit defines how your application scales. For instance, let's say for a credit card company, it can be transactions per second. Or for a B2B company, it can be users. So if you define the function unit, you do calculations, and then finally you calculate the SCI for each component, and finally you get the carbon equivalent per user per transaction based on your function unit. And if you look at the equation, it's quite simple. It's energy consumed by the software system into the intensity at that point of time, plus the embodied carbon, which is the servers, the racks, and everything you are using, divided by the function unit. Now let's look at how you can apply SCI to a real-world application. Let's take an example of a financial application which takes inputs from various data sources, like takes daily data or market data or historical data, and it is basically consumed by a data processing environment which cleanses the data, and then you have an artificial AI component on top of it, which basically generates insights, and finally you have an API model, right, where all the insights are delivered as an API through the compute environment. Now, if you want to calculate the SCI for such kind of digital application, you'll first define the software boundary. In this case, the technology stack itself is a software boundary. Then you go about defining the function unit. In this case, the function unit can be transactions, or it can be based on user. Then you define SCI component for each of these software stacks. And each of these software, right, can have a dependency on other layers. For instance, the AI or analytics environment requires data compute environment to be available. So you calculate SCI for each of these components, and then finally you calculate the total and divide it by the function unit. So you basically get carbon equivalent per the function unit. And then you can basically integrate this as part of your performance engineering to identify what is your software or SCI score, right, after every release. And then based on the three principles which I talked about, right, write energy efficient code, or do hardware optimization, or use carbon aware load shift, right, you can bring down the SCI score. So this gives you a baseline of what is your carbon footprint of your software application. Now when it comes to tools and technology, right, these are some of the tools which are currently, I've listed them, which are currently can be used to measure the software carbon footprint of any software application. And all cloud providers, right, be it Google Cloud, Azure, AWS, are now providing a carbon dashboard, right, where you can look at the carbon footprint of your software application. And there are open source alternatives which you can use to get a view across your cloud stack. Similarly, for AI, you have tools which you can integrate as part of your model building process. There are simple web-based tools where you can just type your web URL and get the carbon footprint of any software application. The one it's listed on the right-hand side is the carbon evaluation of google.com, which you see, right, if you look at the Google page itself, right, it doesn't have much images or any artifact, it's just a simple box. So it has the least carbon footprint, and it's also hosted on Green Region. And next is tools around code base, like where you can integrate it as part of your, let's say, Java engineering process, add tools to understand which code is taking more energy as compared to rest of your stack. And through Green Software Foundation, we have the Carbon Aware SDK, which is coming, which will provide you an SDK on when and where to run run your workloads, so you can leverage clean energy as part of your application. So this concludes my presentation. I just want to give back one thought is, see, we all as software professionals, right, have a responsibility to create energy efficient application and to basically embed the principles of energy efficiency and reduce carbon, right, as part of your entire software development lifecycle process. And we all as software practitioners can contribute towards a greener planet. Thank you all for listening. Do we have time for questions?
Can you guys hear me? Fantastic. Mr. Balani, thank you so much. Who would have ever known that we'd be adding green to software? I mean, that's like a couple of years ago, we wouldn't even think about it. So thank you so much for enlightening us. We are open to questions. So, yes, please.
Thanks, Naveen. Wonderful session and good insights. Couple of questions on the covering other players in the ecosystem. So how is the response of industry on adopting this green software? That's one part of my question. And the second part is, we know the journey of like Android OS and these OS. They have been into world when we had 1 GB of devices. Now they talk about 8 GB of devices, right? So OS plays a major role in these energy consumption when we develop any software on top of it. So how those are responding to this green software journey?
Yeah.
Thank you.
I think it's a very good question. I'll just talk about the first question itself. So from a foundation perspective, as I mentioned, right, we started with 4 organizations and now we have 32 member organizations, right? All are actively contributing towards specification and innovation. So green software, specifically because of the push towards sustainability and ESG, right, is definitely gaining a lot of momentum. And we see a lot of organizations now being aware of how can you embed green software, right, as part of the development process. Because software definitely plays a very big role in your life cycle. And not just software, delivering the software, right? Software will be used by millions of applications or trillions of applications. So now you have the opportunity to develop energy efficiency from day one. So definitely, I would say a lot. In fact, if you look at the foundation, a lot of banking clients are joining the foundation, particularly because they have a higher footprint, right? So definitely they are trying to understand how they can bring their software, carbon emissions down, right, by tackling the software itself in the first place. The second question around OS and memory, right? I think it's a good question. See, if you look at primarily from an SCI perspective, right? That's where, if you look at the second principles that we are targeting, right? We want software practitioners to create energy efficient application in the first place. And hardware optimization plays a very crucial role. So if you develop applications in a way, right, which consumes less energy or use less hardware, right? A lot of hardware optimizations can happen, based on the device that you use, right? So my view is that in future, all these chip manufacturers also, right, would have a role to play to make the hardware more optimized in a way so that we, as a software practitioners, developers, we can leverage the inherent hardware capability, right, which from an efficiency perspective. Any more questions?
Any more questions, guys? Sure.
Hello. Thank you for the insightful presentation. the question that I had is, all of these tools that you have mentioned are primarily focused on measuring the emission, right? Is there anything that is for the developer community where we can start from the libraries on how to develop a green efficient code baked in so that the outcome, which is a greener software, may automatically come in?
Yeah, again, that's a very good question. As part of the Green Software Foundation, we have a project called Principles of Green Software Engineering. So we plan to publish a series of recipes which can help you develop green software applications. And secondly, I also mentioned about the certification, right? Once we release the certification, we'll also release various modules which can help you to design, right, green software applications from day one.
Oh, okay, we have one more question. Let's make that quick.
Thank you for this presentation. So how modernization is different from green software, green computers? Because it's a journey towards cloud, adopting serverless, as you mentioned, it's going to be, and also moving towards new stack, which is going to generate less power.
I think the fundamental difference is we don't, as software developers, right, we don't measure currently, right, what is the carbon footprint, right, of a software application. And once you start measuring it, you can definitely look at applying all these principles which I talked about, right, to make it more energy efficient. Hardware optimization, definitely it's a part of it, that's what I mentioned. So hardware optimization will play a significant role. But if you develop your applications in a more energy efficient way, you will definitely require less hardware and compute to run on it.
Okay, I hope that answers your question. With that, we'll close this round. Mr. Balani, thank you so much. We'd like you to be on the stage for a little more time. You know our routine. We would want to thank you and give you a token of appreciation. For that, I'd like to welcome Bhanu Gupta, the CEO of C# Tech. Thank you. Guys, a bigger round of applause, please. Thank you.
Thank you, everyone.